All right, very good. Good. So this is how computers understand pictures. All right. All right. So let's jump back over to this. Where's this thing? Okay, good. Okay, all right. So this is from IBM. This is from IBM. And again, chat. Can the people upstairs see the screen? See the screen. 05E demo CNN. So let's start at the start. Okay, so basically, yes, okay, everybody can see it. Okay, so just follow along for me today. So I'm in Google Colab, right? And I'm in Google Colab, and basically what I did was to upload the file to Google Colab, right? I'm going to make this file available. Full disclosure, as I said before, it's not my file. It's a file from IBM, right? I did a bunch of courses from IBM, Deep Learning.ai, Stanford, Microsoft, Google, bunch of them, right? But anyway, so let's look at this. So basically, like we said, we're trying to classify 60,000 color images, and they're all 32 by 32, right? And if you remember, I did a little thing the last time where I said that an image is basically looking something like this, right? Basically looking something like this. You know, if you have a 4x4 image, or let's do a 5x5 image, right? I don't know if you guys were able to see this, but basically we're upstairs and we're making the color of a L, right? Right? And when we say it's 5x5, we mean it looks something like this. Right? This is a 5x5 image. Yeah? This is a 5x5 image. And this is what an L would look like as a 5x5 image. This is what an L would look like as a 5x5 image, right? Just to give you a context. An A would look something like this. An A might look something like this. Right? It might look something like this. Right? That's a 5x5 image of an A. This is a 5x5 image of an L. Now notice that you have a single color here, black and white, right? But in reality, we have, so if you look at these images, they are 32 by 32. So that's 32 by 32 pixels. Now each pixel can have 3 colors. Yeah. So what are the 3 colors? RGB. I never heard of a color called RGB. I'm just messing with you, man. What's the R for? Red, blue, and green. Yeah, beautiful. Excellent, right? So this is really 32 by 32 by 3, whereas this is 5x5 by 1, 0 or 1. The 1 bit is 0 or 1, right? All right, good. So that's the images. We have 10 categories, 10 classes. Yeah, this is a classification exercise. So we have 10 classes, right? Can be an airplane, deer, horse, truck. Yeah. All right. So 10 classes. So 6,000 images per class. Notice that we need a lot of images for image classification. Many, many, many. You have to understand that computers are dumb. You can show a kid, I bet you take a 3-year-old, never seen any of them, show them 5 birds, 5 trucks, 5 cats, 5 deer. The next one, they can't tell you what it is. I guarantee you, right? Smart enough kid. Smart enough kid who's paying attention. Yeah. And if you give them enough cookies, obviously, right? Give them enough cookies, fuel their brain. Yeah. Guarantee you, the 6th one that they say, they can tell you, oh, that is a cat or that's a frog. Yeah. Computers need hundreds, thousands ideally. Yeah. So we have 6,000 images per class. Right. All right. Very good. Now, the only thing, of course, the difference is that with so many images, the computer will be able to see, will be able to detect partial versions of these things. Right. But I guarantee you, even so, even with a 5-year-old, if you show the 5-year-old the ear of a cat, right, or the tail of a dog, right, or the bow of a ship, right, or the eye of a horse, they can still tell you, oh yeah, that's a horse, right? But anyway, computers are dumb, so we need lots and lots. Now, first thing we're going to do, we're going to import the libraries. Remember, Python, Visual Basic, C++, all of these languages that what are called libraries. The whole language is fairly small. Well, the language is fairly small. In other words, when you load up Python, when you say, okay, we're going to run Python in Colab, it's loading a small subset. Yeah, it's loading a small subset of the actual language. It's showing a small subset of the language. It's showing a small subset of the language. Showing a small subset of the language. I think I'm not the host. Anyway, nobody sees my ugly face. All right, very good. So Keras is the library that helps us to do deep learning. Yeah, Keras is a deep learning library. Yeah. You have Keras, you have TensorFlow, you have PyTorch. These are some deep learning libraries. Yeah. Now within Keras, you have a data set called CFAR10. Now remember, the data set is the database. Data set, database, same thing, right? But we call it a data set when we talk about machine learning, deep learning, etc., etc. Yeah. Sequential, now we're going to have layers, right? As we said, the neural network is going to have a bunch of layers, right? Sequential is what allows us to create the layers, right? We're going to have different layers, and we're going to look at what the different layers look like. Sequential allows us to have different types of layers, right? We'll look at those. Now, we're going to look at these. We'll come through it. Dense is the normal neural network layer. Yeah, is the neural layers, right? The neurons, layers with neurons, right? Dropout, we're gonna find that this is something part of what's called regularization, where it ensures that the neural network is not overfitting. Activation, we talked about activation. So first it calculates the y equals wx plus b. Then it says a, the activation value, is equal to sigma times z, right? So sorry. So yeah. So first we have the remember, first we have first part of the neuron does z equals wx plus b, right? And then the activation, in other words, the signal coming out of the neuron, the actual signal coming out of the neuron is g times z, right? The activation function times z. Remember, you know, activations can be sigmoid, tan h, relu, etc., right? All right. And remember, the activation is just like a filter that filters the signal coming into the neuron, right? And decides how much to send out of it. All right. Now, conv 2D and max pooling 2D are the real key parts of the convolutional neural network, right? What happens here is that it applies filters to the image to detect things like edges, dark spots, lines, horizontal lines, vertical lines, etc., right? And of course, we have matplotlib, which is going to plot the data. All right. Image data generator is important because we can't load all the values. We can't load all of the images at the same time. These images take up a lot of space. So what image data generator does is it loads it in batches, right? Because the GPU has a certain amount. All right, think of it like this. You have a file on the disk, right? You have, let's say you have 1,000,000 Excel rows on a disk. Let's say a very limited RAM. So when you load that Excel file into data, you'll notice as you're scrolling, it takes some time to scroll, right? What it's doing is it's loading different portions of the file from the disk, yeah? As you're looking at that portion of the file, yeah? The parts that you're looking at in Excel are what you call the cached versions, right? But most of it is on the disk. Now, if you have enough memory, it's going to load everything into memory, right? And you probably know about swap space, virtual RAM. Anybody know about virtual RAM? Virtual RAM, swap space. Basically, what the computer does is it uses portions of the hard drive as memory, as virtual memory. Yeah. Not physical RAM, but virtual RAM. All right. TensorFlow is another library that's used for deep learning, right? All right. Very cool. Now, so one time, let's, okay. So we run this. Okay, so let's keep going. Let's keep going. Okay, all right, good. We talked about X train and Y train. Remember, what it's going to do is it's going to split the data set, right? Data set same as database. So we have the 60,000 images. It's going to split the data set into 50,000 train, 10,000 test, right? Why we need to do that? Oh, you can think of it this way. You can think of it this way. Anybody remember when you were doing when I was in high school, we had these exams. These practice exams. These practice exams that you used to do. You probably had them in high school. I don't think you had them in university. You guys had these practice exams that you could use. What's the test that you take after high school? You have like a test. We have the common what's it called in India? MSIT that allows you to pass for high school. Yeah. All right. And then when you go from high school to university, you have a set of tests that you can do. Do you have practice tests? University tests. Do you have practice quizzes? All right. Now imagine. So you have this very general knowledge, right? Now imagine though that imagine you have 5 practice quizzes. 5 practice quizzes. Now you're gonna be studying and then you do the practice quiz, right? Then you're gonna use the practice quiz and study. Yeah? Kind of iteratively. Good. Now, so you study off the practice quizzes. Use the practice quizzes to study what topics you need to know, right? Good? All right, good. But what you're gonna do is, if you have 5 practice quizzes, you're gonna leave 1. Or you might even leave 2. So you study from 3, right? And then you want to know, am I ready? Am I ready? So what do? You leave 2 quizzes out of the study. And so now you take the 4th quiz. If you get an A on the 4th quiz, in other words, you're not going to use the 4th quiz to study, right? You're gonna use the 4th quiz to test yourself to see whether or not you're ready. If you get an A on the 4th quiz, it means you're ready. Yeah. If you're not ready, then you have to go back and start all over. Keep studying, right? But if you get an A, it means you're ready, right? Otherwise, you have to keep studying, and then now you take the 5th quiz, and then the 5th quiz says, okay, it's like your final readiness check. This is the grade I expect to get tomorrow on the exam, right? You do the 5th quiz like the day before the exam. But like, let's say you have 3 months. You study for 2 months on the 3 quizzes, right? You work through the exam quizzes, right? You use the quizzes to say, okay, how do I work this problem? You don't know how to work it, you go back to the textbook. You learn how to work the problem, right? All right, so you study that way of the 3 quizzes. Then now the 4th quiz is where, without looking at the textbook at all, you're going to take this quiz. So the same thing happens here. You have, and in reality, you might say, you might have 40,000 train, 10,000 test, and 10,000 validation, and 10,000 test, right? So you train it on 40,000 records. Yeah. You're using the 10,000 as validation. So each epoch, you train it for 1 epoch. So epoch 1, right? You train 40,000, right? You validate 40,000. Epoch 2, train 40,000, validate 10,000. Now you're going to find that the accuracy is validate. You have your test accuracy and your validation accuracy, right? Now, what you're going to find each time is that, like, for example, now, yeah, the test accuracy might be 70%, right? Validation accuracy is 40%, right? You train it epoch 2. Your train accuracy goes up to 80%, right? Because it's learning the patterns in the data more effectively the second time. The validation accuracy might go up to 55%, right? Right? Epoch 3, remember, 1 epoch is a full pass through the data, right? It's a full pass through the data, right? All right. So now this might have gone up to 90%, and your validation accuracy gone up to 70%, right? But you're gonna find that it kind of levels off after a while, right? Because remember, it's learning the patterns in the training data very, very well. But because the validation data is different, the patterns in the validation data are going to be different, right? And then finally, you might find that epoch 5, test accuracy might have gone up to 99%, but your validation accuracy gets stuck at like 85%, right? Then now you use 10,000 test records, and you might find, more than likely, you might find that 10,000 tests on your test, and your accuracy is like maybe somewhere between 80 to 85, right? Something like that, right? So something like that. All right, cool. Now remember, X is the features. X is the features. So X is your, remember that? X is your features, right? Each of these pixel is a feature, right? This is like the shirt. This is like the pants. Yeah. This is like the nose. This is like the eyes. You see what I'm saying? Everybody see what I'm saying? Each image has a feature, right? But in this particular case, all right, we looked at house prices and we saw where bedrooms, square footage, distance from, number of garages, distance from schools, whether it has a pool, etc. All of these are features, X1, X2, X3, X4, right? In this case, what we have is X1, X2, X3, X4, X5, X6, X7, X8, right? Etc., etc. All right, very cool. Very cool. So we have 53,000 train, 10,000 test, right? And we could also do 40 train, 10 valid, and 10 test, right? This is the final accuracy. So meaning this is the model that you're going to give to your users, and you're going to tell them that for every 5 images, it will detect 4 of them accurately, but 1 might be inaccurate, right? Now, of course, this is really usable, but it might be a good start. Might be a good start, right? All right, very cool. Now, the thing about it, of course, too, is that when we produce these, when we produce this, we're really going to produce a vector of probabilities. What we're really going to end up with is a vector of probabilities, right? And so there's going to be a probability of airplane, probability of automobile, probability of deer, probability of truck. Yeah. Now, what you might find, for example, is that a dog and a small cat, you might have very similar probabilities, because even a human being looking at these two things might confuse it. Yeah. But you're going to find, for example, that things that look alike will have similar probabilities, right? So like a truck and an automobile might have a similar probability, but then the probability for a deer, dog, frog is very, very low. Yeah, in that vector. So you get a vector of 10 numbers. Each of them represents a probability. Yeah. That the image is one of these categories. Yeah. And of course, if the thing about it is that you can look at the probability. So for example, if it's 100% probability that's an airplane, then you can have a confidence, right? So you have 2 things coming out of this, the actual prediction, yeah, what it predicts that image is, and then the confidence of that prediction, yeah. So yeah, I mean, if it comes out with 100% all right, if this is 1 0 0 0 0, all right, this is 0.9, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1. No, 0.9, 0.01, 0.01, 0.01, 0.01, 0.01, etc. Then we're sure that this is a truck. Everybody with me? So it's not just like it's random and you say, oh, is it right? Isn't it right? You can tell based on the probability that, the level of confidence. All right, very cool. So we're going through. You can look at the shape. X-train 444. This is the 445th. 445th, right? Remember, we start from 0. 445th image, right? The shape, right, is 32, 32, 3. Yeah. So 32 pixels times 32 pixels times 3 for RGB. Yeah. All right. Very cool. Very cool. Y-train 434 is a single number. It's the category that it belongs to. Yeah. Now remember, very importantly, that we are, so remember what we're doing with the training set is we're feeding the pixels as the X coordinates, right? And the category as the Y coordinate. Everybody with me? So we're feeding two parts to the neural network. We're feeding the pixels, right? The 32 times 32 pixels, right? Along with the actual category, right? And then it learns which set of pixels belong to which category, right? So that's very important. I remember Y, remember X equals features, right? Y equals label, right? In other words, in this particular case, categories, right? 1 to 10, yeah? All right, cool. Features, which is the pixels, and Y is the label, right? All right, very cool. Now, so, all right, very cool, very cool, very cool. So, and this is why we have this X train, Y train, X test, Y test. X train is the pixels in the training set. Y train is the categories. Everybody with me? So, you know, you have pixel 1, pixel, 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 label. All right, category, right? 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 Pixel, 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 category. Pixel, 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 category, right? And this part of the thing is X, and this part of the thing is Y. Everybody happy with this? Very cool. Cypress, you look confused. No, you don't really look confused. You're just distracted. All right, let me see who I can pick up. All right, very cool. All right, everybody happy so far? Remember, you know, these pixels are like these, this is these pixels, right? Very cool. Very cool. Very cool. Very cool. And you can show an actual image from the training set. Yeah. And that's what it looks like. Actually, not totally sure what the heck that is. We could actually show. We could actually show 445. All right. Anyway, you're okay. Oh, we disconnected from the runtime. All right, connecting. All right. All right, very cool. I'm gonna make this available later on. You can run it yourselves. And then now Wednesday, we're gonna go into some of the more technical details. We're gonna meet in the lab again on Wednesday. We're going into some more of the technical details of how this thing actually works, right? All right, very cool. CFAR 10.load data. Right? It's using the Keras libraries. All right, very cool. All right, very cool. All right, this might be a cat. I'm pretty sure that's a cat, right? 3 is a cat. Yeah, but I think that's probably a cat. right? Can send, can do 447. Yes, it's 30123, right? Cat. Let's see what this looks like. Did it finish running? Still running out. Come on. Yeah, goodness gracious. What's it running? What's it running? Did it finish running everything? We're still training. Okay, let's stop this training. All right, very cool. So that's a cat. That's 0 1 2 3 4, right? So this is gonna be a duck, I think. Nope. There. 50. Or 50. That's gonna look like the wolf that ate Little Red Riding Hood. Anybody remember Little Red Riding Hood? You guys never learned that story. 0 1 2 3 4 5. 0 1 2 3 4 5, right? So that should be a dog. Image 500. Oh, oops. Zero, 1, 2, 3, 4. 0 1 2 3 4 5. That's this. 10,500. Yeah, there, right? 0 1 2 3 4. 4 is a there, right? Everybody happy? All right, very good. So enough of that. Now, what we're gonna do is notice what the y looks like, right? Right? Print y train. This is what y train is at this point. Yeah, is that what we call a vector? A vector is a one-dimensional array. Yeah, so that's a there. And then that's the ship. That's a ship. I think it's a lot. Yes, it's like a ship, right? Right. And that's a 0 1 2 3 4 5. 5 is a dog. Yeah, you can see it's very relaxed, waiting on its dinner. Right? Jamaica is like India, though. You know? We don't have these. You know how dogs are a part of the family in the US. Even my sister, you know, she came from Jamaica. And no, you can't call her dog a dog, right? She's a chickens or a Bella. Can't call her dog a dog. All right, anyway, you get the point. Okay, so this is what Y train looks like, right? It's a 10-digit number. It's a 10-digit vector, right? What we're gonna do is we're gonna make them categorical, right? This is what it looks like now. Yeah. Right? So Y train 444 is now, wait, hold on a second. So Y train 30, 500. Right. So it changed. Wait, hold on. Something looks weird here. Y train 30,500. Oh, yeah. It already ran it. That is why. That is why. That is why. For Karen's. Ran it already. Sorry, boy. All right. All right. It's X-ray in 44. All right. So Y train is 4. So when we make it categorical, what's going to happen is that it's going to become, so it's 5. So this is 5, right? When we make it categorical, then it becomes like this. Yeah, it becomes 0, 0, 1, 2, 3, 4, 5, right? That's what happens here, right? It takes the 5 and makes it into a 10-digit vector, right? With a 1 in the position, right? If you run it again, if you rerun it, it takes all of this and does, what it does is increases the dimensions of the array, yeah? It redimensions the array each time, yeah? All right, very cool. Okay, so like we said, 5 becomes, 5 becomes position. All right, let's not waste time on that. I'm getting distracted by that. Okay, now, having done that, we need to do what's called, so, okay, so we have Y train 30,500. Now we're going to do what's called normalization. Yeah, right? We're going to normalize it. And so now, if we do Y train again, all right, so X train, X test. So we convert X train and X test to floats. And yeah, so let's redo X test where we've divided it by, all right. Let's do something. Print extreme 30,500. Right. So it divides everything by 255, right? And that's called normalization. Okay, good. Now, let's get to the interesting parts. Let's get to the really interesting part. So these are the layers of the neural network, right? Now, model 1, this is the model, meaning remember the model is what makes sense of the data. We're going to train the model, yeah? The model is going to have all the relationships, right? That describe the data. The model is what helps us to feed the data. Well, it reads the data and gives us a prediction, yeah? So you feed a picture into it, into the model, and it gets out, you get a category. Bother with me? All right, cool. So we declare the model, yeah? And then we're gonna add what's called a convolutional layer. Now we're gonna go into convolutional layers on Wednesday. What a convolutional layer is, what it does, yeah? But essentially what the convolutional layer does is it detects the edges and shapes inside of the picture, right? Now remember when we talked about the 5-bedroom house, when we talked about the 5-bedroom house, we said something like you could feed number of bedrooms, number of bathrooms, square footage. You could feed whether it's a pool, whether it's near to schools, right? Right? The next layer combines these features and determines new features, right? It calculates new features, right? Comes up with new features. Yeah. So for example, the next layer might figure out whether it's good for pool parties. Yeah. Remember we talked about this? Whether it's good for kids, whether it's good for large families, whether it's good for entertaining. Yeah. So for example, square footage and lots of bedrooms means you can have lots of guests over. Yeah. So the combination of square footage and bedrooms, right? Similarly, what's going to happen when your neural network is it's going to detect the edges, right? It's going to detect the edges and curves, right? Because remember, your L isn't well, your A isn't going to be this nice square thing. It's going to might look something more like this, right? Right? Might have more of a curve, right? So let's say this is a diagonal edge. This is a horizontal edge. This is a vertical edge, right? So your inner layers of your neural network is going to calculate the more complex features. Everybody with me? So things like curves, things like a curve that curves up, a curve that curves down, right? A curve that is vertical, a curve that is horizontal. Everybody with me? All right, very cool. And then you're going to add your activation, right? After each layer, you're going to have your activation. Yeah. We talked about activation already. Then we have something called max pooling 2D. This is where it detects the dominant features that are detected in the network, right? We're going to look at convolutions and max pooling, on Wednesday, right? And I promise I'm going to come very early on Wednesday. I'm going to be broadcasting from upstairs. Then we iron out all of this stuff, all of this transmission stuff. All right, very cool. All right, dropout deals with something called regularization. As we said, you have this test data set, right? And it ensures this validation and test data set ensures that we're not overfitting. You have something called underfitting and overfitting. Underfitting is when the network doesn't learn enough from the data. So for example, if you don't do enough epochs, if you don't run it through it's like when you study. It's like when you study. If you read a book one time, you're going to have some kind of idea. But what's happening is that your mind is like the machine. And you're creating a model of the subject, right? Where you can understand things in the subject. All right. You have a model. One model might be law of gravity. What happens when you release an object? Yeah. When you learn the law of gravity, you learn that when you release an object, what happens to it? It might fall. It tends to fall, right? But then you also have other forces, right? That gravity is one of the forces, right? And most times, 99% of the times, it will fall, right? Unless it's floating. But the point is that, and as a matter of fact, the law of gravity is a pretty good example, because if all you learn about is gravity, then what you're going to think is when you release objects, they always fall. But if you learn about gravity as one of the forces, so for example, you have air pressure. Air pressure makes things float, right? So if you overfit your mind to the theory of gravity, you're going to think everything falls. If you train your mind on gravity plus the concept of air pressure, plus the concept of action and reaction forces, right? So for example, buildings stay up, right? Then you know that things tend to fall unless they're opposed by another force, right? Okay, very cool. Dropout deals with overfitting by doing something called regularization, which we'll look at, right? Flatten is where you take the image after you've run the convolutionals convolutions over it and the max pooling, it flattens it into that single vector that we talked about the last time, right? Where it takes this row, then this row, then this row, then this row, and then you have a single, well, it flattens it to this. Flattens it out to this, right? Because remember, before that, you have X is really PPP, 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 right? And Y is C, right? That's really what you have before. All right, let's give this one more P. Right? And Y is C, yeah? And then it flattens it. Dense is a neural network layer. So it's a layer of neurons, right? This is just the regular neural network layer. And then you have the activation layer, not a dropout layer to deal with thing, not a dense layer, not an activation, right? Now, the softmax activation is what helps us to determine which category it is. And again, we'll look at that in more detail on Wednesday, right? And then you have the model summary. Notice when you do the model summary, it shows you the total number of what you call parameters. Parameters are the things that are learned. Yeah. It's going to learn these parameters. And this shows you the size of the model, right? About 181,000 parameters. Batch size of 32 means we're feeding the model 32 images at a time, right? So even though it's 50,000, we're going to be learning about 32 images at a time, yeah? Here we're compiling the model, right? And we'll talk about this, not this week, but the next week, right? We use something called an optimizer, which does our gradient descent. Remember, we're always looking for the lowest loss. We're doing a gradient descent from the highest loss to the minimum loss. And minimum loss means that we're predicting the values accurately, right? Loss is like, actually, loss is kind of like when you take an exam. If you get 90%, that means you have 10% loss. Means there's a 10% loss of knowledge. Think of it that way, yeah? And again, when you do the practice exams, it's like, okay, you study, you get 50%. There's a 50% loss. You study again, you do another practice exam, you get 75%, right? There's a 25% loss, right? What you're trying to do in gradient descent is you're trying to reduce the loss to the minimum possible. Now, based on your talent, based on the level of talent, based on the way you understand things, based on the way the thing is explained, there's a minimum loss you're going to achieve. You're never going to get zero loss. You're going to always have inaccuracies, right? So meaning, if you think of it this way, in this way, it's like loss is very related to accuracy. The higher the loss, the lower the accuracy. The higher the loss, the higher the loss, the lower the accuracy. Lower the loss, the higher the accuracy, right? Meaning that you've learned the knowledge properly, you've understood the images properly, right? And then now you can accurately predict which image is which category, right? We have a model fit. This is the number of batch images in each batch. This is the number of epochs. This epochs means we're going to run the data through the model 3 times, right? The validation is the test data. So every time it trains the model, it's going to check the accuracy on the test data. And this is what it comes out at, right? So you have epoch 1, the time it takes, the accuracy of the training, validation accuracy, etc., etc., etc. Right? Which is kind of weird because the validation accuracy is more than the training accuracy. But anyway, all right. That's it. We talk some more on Wednesday. And on Wednesday, we do convolutions and math pooling, right? I'll go a little bit more into the training. All right. See you guys Wednesday. Let me go take some attendance upstairs. Anybody needs attendance? All right, walk and talk with me. Walk and talk with me. All right, I have you guys. Yeah. Tell me a name. Just you? Money contact. Yeah, yeah. All right, guys. See you on Wednesday. I'm broadcasting from upstairs Wednesday.
Most of them are there. అసలు వేరే మా ఫ్రెండ్స్ అయితే వాళ్ళు వేసుకుంటున్నారు కాలేజ్ ఓపిక సరే బ్రో మనం కలిసాం మళ్ళీ స్టార్టింగ్ లో ఎక్కడ ఉంటున్నావు ఇప్పుడు అట్లాంటినే కదా సరే కదా రాజు
Doing good. I can enjoy life while young. You know, Sri Lanka, you know that, right? Sri Lanka, you know you have to enjoy your life while you're young. Sri Lanka, don't know that. Sri Lanka.
Yes, Professor.
You have to enjoy your life while you're young. You know that?
You don't believe that.
Sri Lanka, why not? You're not gonna? Nope. You're not gonna shake your professor's hand. Yeah. So what you guys doing?
You're good, Professor.
You're good? Very nice, very nice. Listen, you know,